the topic for this talk came up because this has been kind of an annoying subject.
Pause you. Can you share screen on your side?
Yeah. Okay.
Unless
we
you
should
want the whole
probably.
thing to be people watching you.
Oh.
You're good here. Do it in Hangouts.
Oh.
This is where it's at.
This thing?
Yeah.
Sure.
Perfect. Thank you.
So technical debt is kind of a buzzword, and I dislike it. But it's a real thing that we run into. It's something that we're running into at work, and because this is present on our minds, it was something I kind of wanted to talk about. I'll do my intro now. I work at Chargeback. John over here. We are a dispute resolution platform. We're hiring. I've been coding for a really long time. I think I started coding when I was 9. I've had a bunch of non-technical companies, and I've been working as a coder for a really long time. I like Ruby a lot. I've been working in Ruby since maybe as long as Ben. I don't know. It's hard to remember that far back. So you guys, have you heard of technical debt before? What is technical debt?
From what I've heard, you're right, kind of just passable code to get the job done, and you have to go back and fix it later, and it becomes more of an issue because you gotta refigure out what you already wrote.
Yep, pretty good explanation. I have here additional rework caused by choosing an easy solution now instead of using a better approach that would take longer to implement. This happens a lot, especially if you don't actually know where the company's going, right? Got a little cartoon here. Square wheels. This is also technical debt. You can incur a bunch of technical debt by over-engineering. So can you guys imagine with me some ways that this toilet paper roll holder might become problematic down the road? If you run out of toilet paper, you have to have a wrench to put a new roll on. So like one day the janitor's gonna say, I couldn't get the nut off because it was rusted on there, right? There's a lot wrong with this thing. It sticks. You could put a really big roll on it, I guess. Actually, I think one of the biggest problems with this design is that if you made a design like this, I'm certain that people would immediately say, like, why didn't you build a holder for more rolls? Like, it's so big, it needs to hold more rolls. Put the holder on there. And you get crazy scope creep on this unimportant feature of your bathroom application. Okay, so buying into an improper ecosystem too early, having to change something really complex later on, this wastes dev time now and later. So this is an XKCD comic where this guy is developing a system to pass arbitrary condiments so that he can pass the salt to his friend. This is my definition. Tech debt is anything that prevents rapid change. It keeps you from staying relevant in the face of change. Okay, so I wanted to come up with some tips, some ways to help people avoid tech debt, and some ways that even if you're not in charge, and even if you're just kind of working through tickets, how can you prevent tech debt in the code base? This is kind of a soft skills talk, and this is kind of a stupid slide, but this is important to be humble, because the less humble that you are, the more you're going to fixate on your code and believe that you are defined by your code, but you really aren't. When I'm interviewing, I often ask people questions that I know they don't know the answer to on purpose to see how they respond. And I'm way less likely to hire someone that makes up an answer or that can't just say, you know, I don't know. I appreciate someone saying, I don't know. You can learn from anyone at your company, even people not at your company. Everyone that you ever meet knows something you don't. All right, let's move on. To start talking about this concept, I really wanted to show some code that's actually in our code base. It's in production. I just wanted to talk about the good and the bad. That we have this thing in our code called an accumulator, and an accumulator is not an active record concept or anything like that. An accumulator is meant to help you write integrations. So an API integration or you know, that kind of thing where you're interacting with some other system because we pull data from a lot of places. So the way that accumulators came to exist is basically that it was me and one other guy, and he said, we have to do a lot of integrations, right? I said, yeah, we do. And he said, well, let's like make a framework for integrations. And let me show you what he wrote. The code is actually really good, but it also is high in tech debt. And I may have to change, to show you my editor, I may have to change something in my display here. Just, I don't know. That's pretty good. Use Emacs. So I was going to show you the NMI accumulator. Oh man, we'll make this a lot bigger. So this is pretty simple. You see that it has something called steps. It does a pull and then a transform and then a reconcile. This is kind of like a little ETL layer. It's got supports, I guess, which there's a login support and a date range support. And I kind of want to show you guys how this stuff works because it's actually kind of cool. and then I want to talk about the good and the bad about this. So these steps, you know, it pulls some data from NMI. NMI is a data source. It does some transformations on the data, and then it saves it to the database. Pretty simple. And in here, you can see that there are there's a class for pulling. So it looks like it just goes and makes an API call and then parses XML from the API call. It returns it, and somehow that thing gets passed to the next step. So dang it. So here's the next step. This is the transform. Looks like it just kind of normalizes some data, you know, parses a date, converts something to a float, pulls a card number out. Okay, and then let's see what reconcile does. It looks like it just saves into an active record model called gateway info. Pretty simple, but there's kind of a lot of magic happening here. So I already kind of alluded to one of the magic things, which is that at the end of pull, we just return, parse transactions just makes this hash or an array of hashes. And we just return that to somewhere, and somehow it ends up in the transform step. So I'm just going to show it to you. I know how it happens, so I'm going to show you where it happens. I need to bind a key to making my text bigger. I don't normally have to do that. So this is the actual accumulator. And if you look in here, there's let's Where is that? Well, so it gets this package based on the name of the package that you're using. It gets those step names that you passed in, and then over here in the process method, if I can find it, it calls each step until there are no more steps left. It takes the output from one of those steps, and it actually passes it into the next step. So if we come up here to where process step is, well, I'm just going to search for it. So process step, you see, kind of stores output from each step and passes it into the next step. There's actually a lot of amazing stuff going on in here. I'll show you an example. Right here, we are looking up classes for these different steps based on the names of the steps and trying to constantize them if they happen to exist. The supports that I was showing you, they actually are classes or the modules that get prepended onto the package that you're working with. So this is like a pretty in-depth and a pretty like powerful. Let's get back to where we were. So this is a pretty in-depth and a pretty powerful integration project. But you know, all the code is actually doing is calling a REST API, transforming the data a little bit, and saving it to a database. So there's some kind of a disconnect here, right? Somehow we went from, we need to pull data from this API to like auto-loading classes and like prepending things. Who even knows what prepending is? Prepending is basically, well, can someone explain it? I don't know if I can. No one wants to try? Okay, it's taking a bunch of methods and prepending them to the class that you're working on, so changing the functionality of the class. So to think about the simple thing, pulling data, you also have to think about prepending classes. You have to think about like, oh, how is this support going to interact with this other support if they're both being prepended? It's really crazy, really complicated. So this may be unpopular, but this is my second tip to avoid technical debt. It is to write disposable code, not reusable code, at least at first. So is this a popular opinion among programmers? Why not?
I don't know. That sounds great to me as a beginner because I think that's fair.
I mean, until you repeat yourself too many times, you don't really.
Library code starts to happen. See the repetition, and we want to start factoring that out with the accumulator class, which is now something we call.
If you only ever integrated with NMI, that was a lot of work, right?
Well, honestly, we haven't used it for that many integrations, maybe 20. And it would have been a lot easier to write a bunch of scripts that were kind of ugly and just kind of force our way through that. And what we would have learned, so John had a good question. He said, isn't writing code that you're going to throw away the same thing as incurring technical debt? But well, let me show you. I actually wrote the NMI script. Let me show you the NMI script. I think it's on my desktop. NMI, there it is. All right. So this is pretty easy to understand. We've got a method here that parses the transactions. So I put a comment that says entry point. This is something that we gained from the accumulator, so we'd have to figure out how to do this functionality. break up into day jobs. That's just not pulling more than a day of data at a time from the NMI API. So it queues a few extra jobs. So we get a default start date, a default end date, the username and password. Those are kind of hidden in some of the supports in the accumulator. So we'd have to pass those in some other way. And okay, here's a URL. Here's a mechanize agent. We make the request. We clean up the data a little bit, and we save it to the database. This isn't too bad. I can read this script a lot more quickly than I can read the accumulator code. It's not very hard for me to understand this code. So to answer your question, John, I would say that if you write disposable code, and you come back later, you've got 10 of these scripts. You can find the commonalities. You can write a few simple tools. You can refactor a little bit, and it's not going to be hard to like pull that method out and stick it in another file to refactor, and you're good. Instead of building the whole accumulator architecture. Yeah, the system passed the arbitrary condiment. So this is a really unpopular thing for me to say. Write disposable code, not reusable code at first. But I think it's a good way to learn what parts should be reusable.
So the idea is that you're writing code, especially if you're building an app that hasn't been building out a new feature. You write disposable code, just write something that works until you get an app that can see like.
Yeah. There's this thing that that Johnny T, who knows Johnny T? Does anyone know him? So Johnny T was one of my mentors, not necessarily as a coder, but as a Ruby guy. And he used to always say, make it work, make it fast, make it right. I think that's a Martin Fowler quote or something. So this is make it work. And I think making it work before you try to make it right is a good idea. So I think the question is, what do you mean by disposable code? How do you define disposable? Is that your question? Well, the reason that I say it's disposable is you know that in the long term you're not going to have some script that does this API. You're going to run into problems with like queuing and batching, and how do you pass in credentials when you have 1,000 different credentials to use the thing, and like, oh, I want to parse different date ranges. I want to be able to go back in time, right? But you don't need any of that right now. Right now, you just wrote the thing to work. So any of the kind of structure and control structures and like the complicated logic behind all of those things, you didn't write. And so you have a script that you kind of plan to throw away. You don't really plan to throw it away so much as you plan to make it better as you learn what you actually need to make better. That answer your question? All right. So I wrote here, our intuition tells us to never repeat any code, but I still stand by my advice to write disposable code at first. If you can't read the caption, oh, you can. It says, it would appear, Hopkins, that your gut feel was only indigestion. There's a graph, trending downwards. This can really happen, though, especially in a startup. If you make some bad decisions up front because you think that it's going to be important, you could destroy the company because you could go spend a long time toiling on unimportant stuff and not have a real business. All right. I already showed you NMI without the accumulator. that it was simple. That's kind of the key to it. All right. I kind of want to move on to the next point. This is something that's come up a lot lately, that we'll be working on something and a developer will go off in a cave and just work on something for a long time. This actually happened with the accumulator. My friend that wrote it, who I still think is a cool dude and I like him, he kind of went off in a cave and came back and said, look, I've got this accumulator. You got to check in more often than that. You know, if you're going to stand up and you're like, everything's good. Well, do you have any blockers? Nope. Well, how's that thing coming, the thing that you're working on? It's great. This is not enough communication to actually build software with other people that isn't going to incur technical debt. So you guys have probably heard of the elusive rockstar programmer. There is no rockstar programmer without excellent communication. Now, we can be afraid to say that we don't understand something, to look stupid. We could be afraid of offending someone. We might even be excited to say, I'm going to go off in my cave and I'm going to build the cool, super neat feature. And I'm going to show everyone how smart I am. And the risk there is that you might go waste a couple of weeks before you find out why that thing was a bad idea. If you're going to be a professional, you need to act like a professional and communicate well. This is one of the biggest problems that I've seen in the tech world. I'm sure everyone here is a great communicator, but I'm sure that you've had coworkers or you've met people that just don't communicate what's going on. This is key to preventing technical debt. Okay, who has ever seen a software development lifecycle like this? What's wrong with it? What was that?
It assumes all of that is sequential.
Yeah, it's very sequential. So, you know, let's pretend that we're focusing on implementation. There should be an arrow from implementation, like to design, to analysis, to planning. There should be arrows between all these things, right? And people think of these things in a very linear way, but you really gotta be willing to go back up the chain. In fact, if you go and you start implementing something and it should go back to design and you don't send it back to design, that's on you. You should bring that up on day one, not at the end of the sprint when you say, well, I didn't know all the specs, all right? This brings me to my favorite tip, which is tighten feedback loops. You can tighten the feedback loop of the software development lifecycle by good communication. Okay, what's a feedback loop? It's this chart at the bottom here. So when we're coding, I hope this is the next slide. Yeah. We get to design our own feedback loops. Last night, I was writing a script that writes a query to copy some data from one system, and then you can copy that script to another system to run the query on that system. And because I thought it was easy, do you know how I was testing it? I was writing code on my laptop, and then in an SSH tunnel out on this other system, I was pasting that code in a file, and then in another terminal window, I was running it to see if it had an error, and then I was getting the output, and I was inside a Docker container, so I had to move the file to a working directory, and then I could SCP it down to my laptop, and then SCP it up to the other machine, and then move it into the Docker container, and then run the script. Copy and paste the script into the file on the other one, and then run it, and then get a simple error like a syntax error. Go back. I did that thing like 10 times last night while I was writing this code before I tightened my feedback loop. Okay? Because I had to go through like 20 steps.
But you did feel like a Linux genius, right?
No. Important piece of writing better code, and systemically, like within the context of an organization, it's really important. Just kind of burning through these. Yeah. Oh, look, there's some cool questions at the bottom. So, what takes more time up front when you're first starting on a problem? Which of these two approaches takes more time? Is it the one where you like upload a file and go refresh a site and, or the one where you actually set up automated tests? All right, we've got 1 vote for automated tests take more time up front. We've got 2 votes. They do. The automated tests are a pain, right? Which one feels more productive when you're writing the code? You have this cool new idea, you're like, oh, I'm gonna go bang this thing out. The long process feels productive because you're doing stuff, you're trying things, right? But which one is more productive a year from now? The testing. All right, now we can move on. This is my 5th tip. Stop guessing. Do you guys know what I mean by this? This harkens back to the accumulators. I think that we're going to need to be able to load sequential steps. And instead of just being able to have like an accumulator package step, I also want to be able to like load a subclass of that step if it exists. So I'm going to write a bunch of metaprogramming code to do that. And also, we're going to need these support things. I'm going to make up this concept of a support, which is like a little reusable piece of code. And I'm going to prepend these supports onto classes. And like, don't stop guessing. You don't know what's coming up in the future. You really don't. What if your business changes? Do you know how many bugs we've chased down in the accumulator code? We're trying to do something like, all right, we're just going to go pull some data from authorize.net. They have an API, and it takes 3 days to write an accumulator for it. I've outlawed accumulators. We're phasing them out because it's too hard to troubleshoot them. You're like, oh, which class has this method it's a mess. I like this little bit in red down here. So someday you're going to leave the company that you're working at, and someone else is going to go work on your code. And I guarantee, I do this all the time. I'm like, git blame this file. Like, who wrote this? I've actually met people that know my name, but they've never met me. We're at a conference or something, and they're like, "Oh yeah, you wrote all the Stork code in Alliance Health," and I'm like, "Sorry." Actually, the Stork code was one of my favorite projects. It was really good, really well written, but that's pretty rare. So don't guess. Yes.
Is that like pieces though, like original definitions of all? The original definition is kind of like doing easy things, causing growth to happen later. Your definition is
Anything that stops you from being able to change.
I found out that most difficult changes happen from over design. Over design. And over.
It can go either way.
Yeah.
It's a feel thing, right?
Certainly has and like accumulator happens because feedback is a type. You start going, going, you just extract it. Hey, see that happen? I'll do that. If I'm doing extra time, I'll just keep going. Very objects for this. How much you know?
Yeah, it loves you, but all your coworkers
Yes,
hate
I
you.
mean, like, it's like, it actually is kind of, you would look into a file, and you would try to like, figure out what this does. Good luck. I'm sorry, but that's a one right that is. I'll check it.
It's true. It's true, and I think part of finding that balance of not being too simple and not being too complicated is just an experience thing. But I actually think that a lot of it you can promote a lack of tech debt through like a regimented and careful process that you use when you're solving a problem. And the hard thing about that is that programming is a lot of fun. Programming is the most fun when you aren't following a regimented process, when you're like exploring this cool little world that you're messing around with, right? So if you do that, just beware. You might be creating more tech debt. I have a little more about preventing. This is a really good point, Danny. What were you going to say, man?
I just have a few thoughts, kind of around this, not at this, but like you're going on the bottom here, right? And to work at, you know, there's a developer there that would over-engineer everything. Let me ask you this question: did the person who wrote the accumulator ever get fired or laid off?
No, he ended up quitting.
Right. Okay. So we call it security, right? Because nobody wanted to like get rid of it. So you could be perfect. There's a guy who intentionally do that. They grow the rest. So I've actually worked with them before, but also just
Well, I will say in this case, I know that his heart was in the right place. Yeah. We didn't know anything about the business, and he was just trying to build some tools. But yeah.
Oh. not exactly all right, so other point was, yeah, the get blame thing, like, you know, you always have to rewind, figure out, I don't know what that person was going through when he wrote that code, so that's not fair. Because was it right after weekend?
The script that's actually which is its own kind of problem.
It is, it's its own kind of problem, but it's an easier problem to solve.
So I guess for me, getting back to kind of Danny's question here is like, for me, the key to technical debt is writing modular code that can slow down. So not so much script versus pretty small, or just so interchangeable.
A long script
Yeah, for sure.
You guys are touching on something I think is really important, which is how many code dependencies are you accidentally creating with your code? So if you're going to make a modular structure, that's great. I'm all for it. But if you have like this method and this method and this method and this method all work together in a bizarre way, that's a problem. And if you do that with objects, that's a bigger problem. And if you do it with a lot of objects and a lot of methods, yeah, it doesn't help you. So part of I'm not saying you don't know this, but part of that modular coding is keeping the number of dependencies or interdependencies really low. And if you can't figure out how to do that, you need to resimplify it.
I will say, I actually like the premise of the accumulator being simple to itself in workspaces. I like having a pattern of reusable extensive model across different This is just great.
It is.
When you've got to the accumulator that is quite nice.
So we've begun rewriting the functionality in Q1. So for example, there's a date range support in accumulators. And what it does is it specifies like a start date and an end date. And you can pass those in. You can pass in like a few different, like this year kind of things. And it will set up the right date objects. It makes sure that we found out that in Sidekick, in some scenarios, if you pass a date object into a job, it will crash. So like you should pass it as a string, and like some parsing logic and stuff. And, like this stuff isn't hard to write, but it's just kind of annoying, right? So instead of making date range support that gets pre-appended onto an auto-loaded package class, we just made a little date range tool and a little reusable class that, you know, we just like give the input to it, uses the dates, we're done. So, you know, that's a good example, I think, of kind of simplification where there isn't a dependency on that tool. The only dependency is that you have to pass some kind of input that understands, which it understands lots of kinds of input. And then the other details don't matter or don't exist. Should we move on? Good. Tell me, future boy, who's president in 2017? Donald Trump. Donald Trump, the reality TV star. Who's the vice president? I don't know how to say this name. Pat Sajak. Do you know who that guy is? It's the Wheel of Fortune guy. If you guys want to keep talking about the old point, we can, because it's one of the coolest points in the talk. This one's boring. right, so my next tip is to write tests. This is something that we all know about. Make them automated, tighten your feedback loop. You don't have to figure out how to go set up your code. Your coworkers don't have to figure out how to set up the code. They can go read the tests and find out what the expected functionality is. And nothing's going to break your code on accident if you have good tests. There aren't going to be side effects from somewhere else. This is probably the most powerful way to prevent tech debt because one of the biggest sources of tech debt in our code, which doesn't have 100% test coverage, is that we'll change something and something over here, will suddenly break. Like you turn off the water in your house and your car explodes. Why that happened takes a minute to figure out. Venus, gas clouds, I don't know. I'm going to move on because testing is obvious. I wanted to talk about comments a little bit. A lot of times we get funky code. We find funky code in the code base and we can't figure out what it does. So, I see comments get out of date with the code. I see comments that just rephrase what the code does, like open the file. Check if the file exists. Really, those are not very useful.
Somebody's metaprogramming.
Yeah, that might be where it came from. You should be sharing overall ideas. If you were telling your coworker how the accumulator class works, you'd say, okay, it's got this concept of steps. Each step is loaded as an action class. The action classes do things. You can specify the steps in whatever order you want inside of a package file, right? That should be in a comment somewhere. The comment shouldn't say class definition for step. That's not useful. Okay, I want to show you some code. Different person wrote this code, and I want to ask you guys. There's one more end that's getting cut off at the bottom of the projector. I want to ask you guys what this method returns. So it's got comments. It tells you to pass in a list of alerts, by which the original author meant an array, I think. And I brought up this code because we recently had to modify this code, and it was really hard to figure out how it worked. So you see we've got creators.map. Creators comes out of the alerts. So alerts is like active record objects. So we say creators.map, and then we turn each of the creators.map into this, if you go way down towards the bottom, this transposed, flattened thing. And then we do some crazy inject thing. And I don't know what this is returning. We're getting back like an array of arrays or something. We're transposing it. We're flattening each of the internal arrays. And then we're making a new array of arrays and
Transforming it to what somebody wanted.
yeah, so this one of the reasons that this code is really confusing is it has an interdependency. If you look down there where it says parse update response, that's another method. So at some point, this thing is doing something with parse update response and getting back presumably a two-dimensional array or something. And then it's doing this transpose. It's really hard to figure out what this code is doing. So we stepped through this code. Actually, it was John and I. We stepped through this code. We figured out how it was all structured and what was going on. And hi, guys. Welcome. We ended up just putting a couple of comments in this code because I didn't really feel comfortable trying to refactor it. We were in a bit of a hurry. And I'll just show you these. I consider these to be good comments. You might not, but the reason I consider these to be good comments is that they explain what the heck the data type is, which is the part that's confusing. So this transpose map flatten gives you back an array of successes, an array of failures, and then that inject thing is like an array of success and failure arrays. This was enough for us to figure out how to like mess around with the code. I didn't want to refactor this code. I was sure that I would break some stuff. It's been running in production for 3 years, 2.5 years without being changed. Someone made a change to the code and broke it in a weird edge case. We couldn't figure out how to fix it. I just left those comments after we fixed it, and I didn't try to do anything else to it. Which kind of brings me up to this point. This is tip 8. When considering refactoring, pick your battles. Who has ever refactored code to make it more readable and broken something and not known it for months at a time until they figured out that they broke it by refactoring it? I think all of us probably have. If you say no, it's because you didn't find out yet.
Years, maybe?
Okay, I was reading all these blog posts when I was thinking about this, these slides and stuff, and I read this blog post about opportunistic refactoring. Someone was saying, hey man, every time that you're in there changing code, you should leave it better than you found it, which he called the Boy Scout principle. You should refactor that code and you should fix it. And these questions at the bottom are mine. How good are your tests? How big is your team? How long is your backlog? I guess if it's a startup, I could say, how long is your runway? How large is your organization's tolerance for bugs in production? So I do not recommend refactoring at every chance that you get. I think that it's a good way to cause more problems. This is John's recommendation. John, do you want to tell us what you mean by code for an audience?
Well, I just meant that other people can have to use the code. So you should code with that in mind. And code like something you watch over your code.
Yeah, so one of the things that we keep on discovering in our pull requests at work when we're doing like code reviews is this code works. And if I read all of the code, I understand how it works. But if I don't know how to use it. There's not like an entry point for me. It's just like this big thing. I don't understand it unless I go read the whole thing. Your explanation was right.
No, I just remember what we were talking about. What we just
So make it obvious how to maintain your code. Put a helper method in there. Name the arguments something that's not A, B, C. And don't be clever. You remember that crazy transpose weirdness code? There's no reason. Should we go back to it? There's no reason to take the request or take the responses and figure out if they're successful or not, and put it in an array, and then transpose that array, and then flatten the results, and then run it through inject. It's crazy. It's messy. It's really hard to understand. Sorry? Not always. I think sometimes more is more. Like sometimes if you have one line of code that has 3 enumerable methods in it, if you wrote that in 10 lines of code that I can read and make sense of intuitively, then more is more. But less can be more. What were you guys talking about? Over here, I missed it.
I was just curious, all that was written at once.
I didn't hear you.
If all that was written at once, or if it was like
Probably.
over time.
No, it was all written at once, and then it hadn't been touched in years. No one had ever touched the code. It was just clever. It wasn't bad, but it was clever, and it was really hard to understand. And this is my opinion down here. If you know something isn't well designed, like, you should put a comment in there. This is a piece of crap. If I had more time, I would restructure it this way. Right now it's structured this way because of these reasons. Good luck. That's right. There are comments like that all through the code base for me. I'd show you one, but I don't know where they are.
I put refactor comments in PRs and stuff, I think.
So this is my last tip. It's to go read code that has already gone through the refiner's fire and try to learn from it and find out why it was changed the way it was. I find that a lot of people don't read code. I go read gems. If I'm running into a problem, I'm deep in the gem. I'm looking at how it all works and figuring it out. And I can read code really fast and I can make sense of it really fast, but I didn't used to. I used to be really slow and it used to be really, really, really hard. And it's worth it to go read big code, to go see how like arrow works or whatever. Go read big code. This is my last slide. I don't remember what all my 10 tips are, but they were basically like, don't paint yourself into a corner, communicate well, don't be a jerk, write specs. That's about it. So thanks for listening. Does anyone want to bring up another concern or question?
One other thought I had when you brought up your process chart, right? Whatever you want to call that, project management, right? My problem with that is very different than any else problem. It's that I don't have 3 of those boxes, so let's see. It's oftentimes that it's okay. When you're building new projects, right? I mean, something like this exists well if you're just punching out words, right? But where it fails miserably is in any experimental coding, any creative coding, we need to figure out a solution for this, and we don't know the answer scenario, right? And it's difficult, like many problems, most processes fail right there, as far as like the proper way you want to be doing things. Like it's an argument against TDD, for instance. How do you TDD well if you don't actually know every step along the way? Writing tests after you figure it out sometimes. So that seems nice, but you're right. I agree with the premise. If you have that in place, going back up the chain is perfectly appropriate. Oftentimes, people aren't given a realistic shot at. We don't have perfect product guys who deliver a perfect spec to a project manager who outline it correctly, put in fill out the feature request properly, and get the designers to do the required. Right.
So I agree with you, Ben, but I also think that if you don't have someone doing product design and if you don't have someone filling all of these roles, they're still important. Just like when you write some code, someone's got to QA it. If you don't have a QA guy, you should QA it.
Right. That doesn't mean one person can't be doing every process.
Right.
It's not so long.
Yeah, I mean, I'm just thinking through. In certain places I've been, we've absolutely had that structure, and it's been good to say. It's been convenient as the developer to say, I can't do it. But at the end of the day, the task still needs to get done, right?
Yeah, and the better approach, if let's say the designer failed to do her job, you go to the designer and you say, I have some questions about this. Let's work through it. And you can short circuit this. Like you don't, this is what I dislike about the chart is that it, like you said, it's so linear. But you can just tighten that feedback loop and go right back to the design and go, hey, this seems weird. And you guys might realize, hey, we need to go back and replan some of this. Let's go back to the guy that came up with this idea and let's rethink this a little bit. So this was all part of the tighten the feedback loop tip. Why we were talking about this, and there are loops like that all over the development cycle. It's not just when you're writing the code for a ticket. I mean, there are feedback loops like everywhere, and anywhere that you can tighten the loop is going to decrease technical debt. I like that comment. Anyone else? All right. Tests as technical debt. I like that. Actually, now that you say it, yes. There are things in our code base that now have tests that didn't for a long time because they had not yet reached their final form, right? There have definitely been times that I have said, don't write tests because we don't know what it's going to end up like. So yeah, if you write tests for something that's going to change a lot, then that's definitely technical debt. So how, I think the implied question is, how do you go about testing stuff that isn't ready to have like formal specs written?
That's pretty subjective in my opinion.
It is.
Like,
I don't have the answer.
because one would make the argument any can be tested. That's where defaulting to unit tests alone or integration tests alone.
I think you're kind of right that unit tests might make it harder to change your code because you have to go fix the tests. What I was going to say when I asked my provocative question, how do you test stuff that isn't done? What I was going to say is you can write a test that will still be true even if you change how it works, which is like a giant kind of black box feature test. So taking like the accumulators / raw NMI script example, you could like mock out an endpoint and say something ended up in the database. That's the whole test. And then later, if you restructure it, you can still get the same test, which should still pass. Are you taking off? Oh, thank you.
Thank you so much.
Yeah.
Thank you.
Take care.
See you. Yeah, but I think that's like, do I test the inputs and outputs, or do I test the guts of the whole thing, right? Every input is really
you do payment related things. You probably should.
Well, sometimes I do payment related things.
Yeah. I think testing can I mean, going back to your original premise, technical debt is anything that prevents you from being productive, right? So I think it.
Something had shared, something about the car was coupled to something about the closet. It's actually a problem all the time. It's sharing. Nothing is shared, then they can change whatever you want.
I agree. Got to decrease the interdependencies that don't make sense.
So I liked I think it was your second point. It's like the notion of write stupid code versus smart, disposable code versus reusable code, right? Because, at the end of the day, like, programmers like putting things in boxes and playing code golf, and we like doing these things because they're fundamental exercises. People don't like the way that people organize other people's boxes. Like, that's just true in general, right? And if your wife organizes her closet with yours, then, that's okay, right? Or whatever. So it's interesting. I think I strongly agree with the fact of I'd rather see you have the same code repeated 2 or 3 times than it be so damn clever that nobody knows how to use it. Right? I'd take that any day. If it's modular nature, I'd actually take your 10-line script over 6-class method with 2 methods each, or 6-class structure with 2 methods. If it were just something that's, depending on the use case, of course, but if it were something like in your case, I assume the notion here is we have to integrate with 20 different payment providers, and so we want a common recipe book to integrate with people to simplify our things so it doesn't become too crazy, right? That's the notion behind the accumulator, if I understand it, right? And so in that case, I'd rather just see the process method for Mantive or anyone or whoever it is that at least the process method is understandable. I knew exactly what this was. Transaction that you had to parse through. Because a lot of times people get caught up with the stupid part of it, like in your code, like NMI, you were using no library to parse through HTML, it looks like, and CSS selectors and things like that. Your other providers, you have a good JSON API, and another one you have a crappy SOAP API, and another one you have an okay XML API, and it's not concerning itself with any of that. I don't know that I'm into your point.
Well,
But
it's interesting what you're saying. There's a lot of work to put into the application form. A lot of work to put into step system.
yeah, which had
That's
The-
like
the step system-
right.
So the step system is actually really problematic because as we were building more integrations later on, we found out that sometimes we wanted to be able to just run step 2 on its own
Right.
and not have
In
to go to
isolation.
3, 4, and 5.
Yeah.
The way that we've kind of landed on to redesign that architecture is we have service objects for dealing with the insertion object or insertion logic, I meant, and all of the integrations just use the same service objects. And then what the integrations are doing is getting data, putting it in a format the service objects understand, and then just handing it to them, which I think is a good compromise. That might not work in a different setting, but it works in this setting. So
So as you were talking about that, I pulled up a code thing of my own.
Do you want to show
Yeah,
it to
I
us?
do actually.
Go for it.
It's a similar and different problem where it was something that, okay, so in our app, basically you can buy coins or you can earn them through advertising, just like any other game, right? And so we have this notion called ad providers.
Do you want to do the screen share thing? I don't know how to leave it.